We are now going to introduce vector fields. This phrase sounds so fancy with this word fields, but let's just say it's really not as bad as you think it is. Let's draw this little chart just to compare a couple things. So first of all here, let's put in the number of inputs and then the type of output. All right. Number of inputs, you can have one input, or you can have, let's say, more than one input. And for more than one, we're just going to focus on two inputs or three inputs. As far as the types of output, we can look at the example of output being a scalar or output being a vector. Now, let's fill in this spot here. Okay, number of inputs, one input, or rather, let's maybe clarify number of input variables. Okay, so let's fill in this spot. One input variable, and the output's a scalar. I mean, this is the type of function you have dealt with for a long time. For example, f of x equals sine of x minus, say, 2 to the x power. This is one example of a function that could be here. There's many, many functions, of course. Practically every function you've ever dealt with, probably every function you've ever dealt with in Calc 1 could fit there. Then let's fill in this spot over here. Okay, so one input variable, but the output needs to be a vector. So this is the content of vector functions. So if you look at vector function, that was, I believe, chapter 13, section 1. So, for example, let's write in an example here r of t. So t is that one input variable. And you could have the output being, let's say, the vector cosine of t, comma t squared. That vector is the output. We've also seen when the output is a vector in 3D space. So how about cosine of t, comma t squared, comma, let's just say t over ln of t, for instance. All right. So the examples we're seeing here, the input is one thing, namely a real number called t. The output is technically one thing. It's a vector. So for each t, you get a vector. But how much information is in a vector? Well, there's two real numbers if it's a vector in 2D space, and really three real numbers, the numbers being cosine of t, t squared, and this fraction if the vector's in 3D space. Now let's fill in over here. Okay, so then what we did was we looked at then functions of multiple or several inputs, or how about let's just clarify input variables. Okay, that was really what chapter 14, section 1 was about. So with two input variables, we looked at things like f of x comma y equals sine of x minus 2 to the y power. With three input variables, like f of x comma y comma z is equal to z times sine of x minus 2 to the y, something like that. So we dealt with functions that look like this or like this throughout chapter 14. Now it's time for the new stuff. Now it's time to look at vector fields. Okay, so the title of this section, so this is chapter 16, section 1. Now what we do is let's look at the case of, say, two input variables. So as an example, the notations usually, the book will usually use a bolded F, but that bold is meant, because we have a vector, we're going to draw an arrow on paper though. And the input variables like here are usually called x and y. And then what we're going to get as an output is just like over here, a vector. So for example, you could have the vector negative y comma x. And then, as an example with three input variables, you could have, here's the example, capital F arrow of x comma y comma z. And this just needs to produce a vector as an output. So for instance, because there's 3 input variables. Usually we end up with a vector in 3D space. That's usually most natural. So let's just do that. How about like negative y, comma x plus z, comma, let's say y squared z. All right. So this new concept over here, it's, I guess they don't want to call it a vector function, even though the output is a vector. I think they just wanted a new name to emphasize that the input is no longer just one thing. Like over here, the input was just t. Now there's 2 input variables, x and y. And this is all we have, right? So definition, we already gave examples, but we're just going to provide a definition of what's going on here. This is a vector field. Okay, is a function. All it is a function. Okay, let's put in that notation, typical notation. Either f bolded or f with an arrow, capital F with an arrow on top, with either points x comma y in R2 as input and a 2-dimensional vector as output, or points x, y, z in R3 as input, and a 3-dimensional vector each time. So each time you have your input of a point in R3, then a 3-dimensional vector is output. Output. So these are our examples over here already that just kind of hinted at the definition we gave. So let's do the following. Let's look at the first vector function that was already defined up here. So we're going to just rewrite it down here. So let's let capital F arrow of x comma y equal, in angle brackets, negative y comma x, close angle bracket. Of course, the other way we could notate this is negative y times vector I plus x times vector j. So based on this vector field, let's compute. We'll just find f of 1, 2. We'll find f of 1, 3. Let's find f of 4, 3. And f of 0.5, comma 10.2. So don't overthink it. There's not supposed to be a lot of work involved here. Just be very consistent with notation. All we have going on here, right, is, okay, right here, 1 is x, 2 is y. Just plug in, right, and we'll get negative 2, comma 1. So when the input is the 0.12, the output is the vector negative 2, comma 1. What about f of 1, 3? So negative 3, comma 1. When the input is the 0.13, the output is the vector negative 3, 1. What happens to 4, 3 here? When the input is the 0.43, the output is negative 3, comma 4. And then one last one here. So all we're doing is putting as the first component negative whatever the y value was. So negative the number 10.2. And then the x-coordinate, just unscathed, ends up as the second component of the vector, so 0.5. That's it. Let's do the following. Look at another example. So we'll consider the vector field, capital F arrow of x comma y comma z, defined to be angle bracket negative y comma x plus z, comma y squared z, close angle bracket. So this is the example just shown earlier. So what is, take this vector field and find out what happens when we use as input 3, comma 4, comma pi. Okay, so f of 3, comma 4, comma pi we should get a vector based on what's written there. Yeah, so negative and then y, so 4. Negative 4, comma x plus z, so 3 plus pi. And then y squared z, so 4 squared times z was pi. And that's all. Now, as the interactive question, let's do the following here. In your own words, think something like 1 or 2 sentences. Give 1 or 2 sentences. What is a vector field? Okay, try not to use my words. Try to really process what's happened so far and put it in your own words. And then give an example of a vector field.